So this is from Module 7, from letter D. This is the draw the mechanism and product for the nucleophilic addition to a carbonyl. This includes a strong nucleophile, and it is under basic conditions, which is the Wittig reaction. And the Wittig reaction is an aldehyde or a ketone reacting with a triphenylphosphonium ylide to form an alkene and triphenylphosphine oxide as the products. In this reaction, you have a ketone triphenyl phosphate group, alkyl bromide, butyllithium, and they actually all react in order to form the products. So to begin, you start off with an alkyl bromide, and it first reacts with the triphenyl phosphate group, and then it reacts with the butyllithium after, like step 2, in order to receive the ylide. And from there, the ylide is then able to attack the ketone, and then the product of the alkene forms along with the triphenylphosphine oxide that is formed. And the mechanism for this reaction includes all of these compounds. So you start off with the alkyl bromide, and you react it with the triphenyl phosphate group. So the phenyl has the phosphorus has 3 phenyl groups coming off along with a lone pair. So from there, the bromine is actually very electronegative, so it is going to be partially negative, while the carbon is going to be partially positive in the sense because it withdraws electron density. So from there, the lone pairs on the phosphorus will attack the carbon, and then this will cause the bromine to be thrown off along with the electrons coming onto the bromine, so you will get a negative charge on the bromine. From there, you will then receive this phosphorus with the 3 phenols, and that will be positively charged because it will have 4 bonds. The phosphorus will have 4 bonds. From there, this will react with the butyllithium, and now the butyllithium is a very strong base, so strong base, which means this carbon will actually have a partial negative charge, and this lithium will have a partial positive charge, or you can think of this as being a carboanion, and then this being the lithium with a positive charge, because the bond is polar covalent here, or ionic. So from there, the lithium will actually want to, the butyllithium will want to attack one of the hydrogens that's coming off of this carbon over here, because if the hydrogen is taken off, the electrons will move to this carbon, and that could actually be resonance stabilized by the phosphorus. So this will attack the hydrogen, and then the bond will break and the electrons will come onto the carbon, and then this will be, so this hydrogen is fairly acidic because of that resonance stability, so it will be taken off, and what you will get is the ylide, and then it will have a negative charge on the carbon along with 2 electron pairs, 2 lone pairs. So from there, once you have the ylide, you can react it with the ketone in step 3. So you have step 3, which is the ketone. And now the ketone has, since there is an oxygen, it withdraws electron density. So this carbon will actually be partial positive, while the oxygen is partial negative. And this lone pair will then act as the nucleophile and attack this carbon, which will cause the bond to break and the electron electrons to sit on the oxygen. From there, you will receive this intermediate. Which is intermediate, which is called the butane. Now the phosphorus will also have a positive charge, and now the oxygen has a negative charge. So from there, these two have opposite charges, so they will attract. In this case, because of electrostatic interactions, they will actually form a bond. So the oxygen lone pairs will attack the phosphorus, and then you will receive the four-membered ring. And then the charges will be neutral. You will receive the four-membered ring. Which is also known as the oxaphosphetane. From there, you will then go through the breaking of bonds. So in other words, this phosphorus is less electron negative than the carbon and the oxygen, which means it will have a partial positive charge. While the oxygen is more electronegative than both the phosphorus and the carbon, it will have a partial negative charge. The phosphorus will have a partial positive charge, and the oxygen will have a partial negative charge. Now for the carbons, since this carbon is less electronegative than this oxygen, it will have a partial positive charge. And this carbon, since it is more electronegative than the phosphorus, will have a partial negative charge. So from there, once the bonds break, this bond, since this carbon is more electronegative, it will break and the electrons will form a pi bond over here. And this bond that's connecting the oxygen to the carbon will also break and form a bond between the phosphorus and the oxygen, because the oxygen is more electronegative, so it will take the electrons. So from that, you will receive your final products, which is an alkene, along with the triphenylphosphine oxide, and those will have neutral charges. And those will be your products from the Wittig reaction.